Hi, I'm Etta Spencer. Today I have a very interesting thing lined up because I'm going to get acquainted with my brother's next door neighbor. And, and this is Craig Smith. And I think he has qualifications beyond being a good friend of my brother's, but that's how we got acquainted at any rate. His co-author, both of them are very distinguished engineers and businessmen who have been leaders of corporations and so on. So I'm out of my league. We want to talk about energy, how we're going to get the energy that we're going to need in order to maintain an industrial civilization and still bring global warming under control.
Thank you so much for having us today.
And his co-author is Bill Fletcher. Hello, Bill.
Hello, happy to be here.
Yes, and look at behind him. They've got covers of the book on the wall. Reaching Net Zero. It says what it takes to solve the global climate crisis.
Very good.
And it's published by Elsevier in England.
We became concerned, as have many people, about climate change and global warming. We both live in Newport Beach. I live a block from the ocean. Bill lives inland. He's smarter than me. He's on high ground. I'm only 10 feet above mean sea level. So I've been acquainted with problems of rising seas already, and that's given me added emphasis to learn more about this subject. We worked on this book for 3 years. We are not writing a doom and gloom book. I want to make that clear up front. We're optimists. We think that there are things that can be done that are technologically feasible today and are economically practical that can go a long ways to reducing the ultimate dangers that we see coming down the road. The big issue, there are 3 big issues, we think. First is increasing public awareness of this problem. Secondly, there has to be a fee on carbon at some point, some way, to offset the expenses that burning carbon creates by pollution and building up carbon dioxide in the atmosphere. And the third thing is that we need to take action soon. We need to get moving. We've known about this problem for 3 decades and nothing, or very little I should say, has been done.
You're an electrical engineer by training, right? And you do these electrical engineering operations around the world, right?
Yes, early in my career, I did a lot of work on electrical power installations of all types, a lot of nuclear, as a matter of fact. And Bill has a nuclear background also. Later in my career, I was more involved in project management and construction management and all sorts of large projects, from airports to mass transit systems, US and overseas. And even we were responsible for renovation of the Pentagon.
These 2 guys know a thing or two about business and the practical end of trying to solve these problems. And so thank you so much, Craig. And Bill, you are, I believe in your background, a nuclear engineer, right? You worked on nuclear submarines and building nuclear power plants and so on.
Well, we put a lot of thought into what can and should be done. And I think the good news is that the technology today will support a solution. We believe that what needs to be done can be done and is increasingly economical because the cost of electricity from renewables, solar and wind, is continuing to drop dramatically. So what was not possible 30 years ago is more than possible today and is getting to be more practical every day. I think one other thing I would add to what Craig said is the need for unprecedented international cooperation. If one country like the United States or if California or Europe does the right thing, but the rest of the world doesn't follow, you're really wasting your time in a sense because the problem won't get solved. Mm-hmm. And also you'll go to a lot of trouble and expense that may put your economy at a disadvantage on a global scale. So one of the things we have to do is have an unprecedented level of international cooperation, in my mind, in spite of the differences between countries. We think that this is probably an unprecedented level of cooperation compared to what we've had to do in the past.
Well, you know, that's a very stimulating idea because right now it looks to me like we're in a regressive period in terms of international cooperation. I mean, the Trump administration was already make America first and so on. And the competition with China looks to me like it's getting pretty ominous. Do you think it's possible to turn that around and have a more cooperative relationship with what looks like a rival?
There's a couple of things. I mean, China and the US are the world's two largest economies and are really the engine for growth for the world economy, if you face that. And there is a natural rivalry. And I think the real tension between the US and China on trade and the transition of jobs from the US to China are real issues that have to be resolved by both countries. Mm-hmm. And I don't think we can say that those problems have to get solved first. We'll have to live with that and work together on global warming. And the other thing, I think China has a big incentive to deal with global warming and is doing, frankly, in my opinion, more than the United States today. Mm-hmm. They are leading the world in the use of solar and wind energy and the production of electric vehicles and the production of batteries and several other technologies that are key to solving the climate crisis. And they've also targeted these industries as growth opportunities for their own economy and for export businesses. And that I have to include in that nuclear power as well. China now is the leading producer of nuclear power plants. So China is moving quickly because they have some very big problems of their own to solve. One is they've got a terrific air pollution problem, and I've spent a lot of time in China over the years. And there's a public health issue that they can solve. Also, unlike the US, they do not have a lot of domestic energy other than coal. So they have to import most of their oil and natural gas. So to the extent that they can develop renewable energy, that dramatically reduces their need for imported energy. So we think China looks at global warming as a big business opportunity. And it also deals with air pollution, with energy independence, and a few other things. We have a rivalry that will get more intense in my mind.
You live in California. Let's look at California's plans because I think that's the state in the U.S. that's making the most progress toward sustainable sources of energy.
We have one surviving nuclear power plant in Northern California operated by Pacific Gas and Electric.
Is that the Diablo?
Yes, Diablo Canyon. And it's scheduled to be shut down in the near future. I don't remember exactly, 4 or 5 years, I think. And of course, the local plant here, San Onofre, which is 30 miles or so from where Bill and I live, has been gone for several years. And
because of the fires and the liability for causing the fires, I gather that PG&E is financially in deep trouble. How does that impact on your proposals for, or the real California plans for its electrical future.
PG&E is hopefully emerging from bankruptcy or maybe being taken over by the state. It's still not clear. They've had a series of terrible problems. One was a natural gas pipeline explosion due to poor maintenance and neglect, and then he caught the blame for some of the wildfires. So all the publicly owned utilities, Edison and PG&E, are facing competition from firms that are contracting for renewable energy and selling and distributing it. They're not owning the plants.
Oh, so there's competition there.
There's competition, and it seems to be a growing thing. More and more municipalities are now looking at breaking away from the investor-owned utilities.
I used to live in California, and PG&E was all I knew. I didn't know there was anything else available, but presumably PG&E was getting its electricity from the nuclear power as well as what else? How were they already functioning for California's electrical system, and what was their game plan before all of these financial catastrophes overtook them?
You know, I'm not an expert on the public utility companies in California, but they have to provide, according to the California law, an increasing percentage of their electricity has to come from renewable sources. And when they define renewables, they're talking about solar and wind primarily, and they're not including nuclear power in that mix of power. And so they have to basically purchase the power, and a lot of this is purchased out of state. That's another issue of having to buy a lot of power. And then we've had recent brownouts because they couldn't buy enough power to keep up with demand during.
Where do they get it?
Well, I think you can buy electricity anywhere and have it shipped in by transmission lines. You obviously need to have the mechanism.
We have some pilot programs that are promising. One we write about in our book is serves the small town of Borrego Springs in the Anza Borrego Desert, which is inland 100 miles from San Diego over a range of mountains and served by a single transmission line. And if there is a problem or if there's a fire, then that community is without power. It's happened a number of times in the past. So today they have two solar farms there generating solar energy. They have some emergency backup diesels. And they have several large battery storage systems. So if they lose that line today, they can go to their own generation, solar and diesel if necessary, and survive. So that's now known as a microgrid, and it's going to the point where they shut down the transmission line. It's called islanding, like creating an island. So here's an island in the desert that's self-sufficient for some predetermined length of time. I think we're going to see more of that in California. The California Energy Commission has put up funds for demonstration.
I mean, there's a bigger issue here. I mean, where do you get your power? I mean, we're used to, for example, importing oil from the Middle East or from all over the world, and coal from coal mines in, let's say, Virginia or North Dakota, and shipping it hundreds or even thousands of miles to where it is needed. And the same is with solar and renewables. If you look at a map of the United States, as far as, let's say, sunlight, you know, there are parts of the U.S. that are ideal for solar power. They've got a lot of sunlight and a lot of and very little cloud cover. there are other parts of the world, of the United States and the world, that are ideal for wind power. And we were going to have to think, you know, like Los Angeles cannot possibly generate enough energy locally to meet its needs, so they have to import power from a very long distance, perhaps from Texas or Arizona. And so we need to be thinking with renewables of creating the infrastructure nationally that we already have in place for fossil fuels, where we have ocean-going oil tankers, we have pipelines, we have rail cars and things like that. Now, I think California is an exception in one sense, in that we're a very large state. We have a lot of deserts. We have a long coastline, a windy coastline. We've got mountain ranges. So I think that California probably does have the natural potential to produce its own energy if it wanted to, if they wanted to. I mean, I'm not sure. I'm not saying that's a recommendation. Yeah.
Okay. 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 Of course, you only mentioned wind and solar, but there are not only, I would think, have to distinguish between two kinds of solar power: the concentrating solar power and the panels that we're familiar with, but also there are many other potential sources of energy that we hear about in, you know, I read about it on the internet, but I don't see any evidence of it as a practical source of a realistic planning. That'd be geothermal and things like tidal power, ocean currents and things of that kind. Are any of these alternatives really realistic?
Well, there have been examples of all of the types of generation you just mentioned, tidal, geothermal, and so on. But in the big scheme of things, it's a drop in the bucket. I don't personally think, I'll see what Bill thinks, but I don't personally think that they'll ever amount to enough that we can reliably count on it. I personally worked on PG&E's geothermal plant called the Geysers in Northern California, and it's still operating. It produces a small amount of power, but it has, like every source of energy there is, it has a lot of technical issues. The steam that comes out of the ground carries a lot of corrosive materials with it, and so that everything has complications. You put tidal power, you put things in the ocean's corrosive. You know, nothing is easy.
I think probably everybody would agree that nuclear power is in many ways highly undesirable. And I don't think we need to elaborate on the risks, because everybody knows that. But what is controversial is whether we can get to draw down inflection point of reducing global warming in the time frame we need without resort to additional nuclear power. So I read people like Bill Gates saying that it's absolutely essential. And then I read and meet people like this fellow Jacobson at Stanford, who develops a big plan for how to do it without nuclear power. And I don't know what to believe. So I really want to, dive right into that issue. I hear that nuclear is the most expensive, form of energy, that it would take much too long to get there, and because building a nuclear power plant is a real challenge in terms of time, and then of course there are all the other safety features. So,
well,
how do you answer that question when people say, do we need to build more nuclear power plants, or can we do it without it?
You want a short answer or a long answer?
That we've got about 40 minutes yet.
I spoke to you the first time, Meta. You said something about nuclear power, and I said, well, we have to reveal everything, and you're talking to two old nuclear engineers. But we're going to surprise you, okay? So I'm going to talk about the good things, which is going to be real short, and then Bill's going to talk about all the problems. So take a little more time. Now, the good things are that nuclear power plants don't generate greenhouse gases. That's one good thing. I think another good thing, and I've been involved in nuclear safety virtually all my career, I think the risks of major nuclear accidents is overstated, but nonetheless, it's a real problem in the public's mind, and it has to be recognized as a real problem. The third thing I want to say is that our existing nuclear power plants in any country, wherever they are, if they're safe to operate, they should continue to operate as long as possible, just to buy us time to get more renewable energy in place. And there may be some plants that we can even do some minor upgrades and keep them going another 5 years or something, so long as it's safe to do so. Now, having said all that, there's a lot of problems if you want to talk about building new nuclear plants, and I'll turn it over to Bill.
Well, one thing is they are very expensive, and it takes a long time to build a nuclear power plant, and a high percentage of the plants that have been built have been way over budget and way behind schedule. The plants we have about, I think it's about 90 reactors still operating in the United States, and they produce about 20% of the electricity used in the US, so it's very important. However, almost all of those plants are close to the end of their design life. Some are getting extended. And so you could say that essentially all of the reactors currently operating in the US have to be replaced probably in the next 15 or 20 years, just because they're old. There's only
it's
one.
Worse than what the Union of Concerned Scientists said. They said about a third, but you're saying all of them.
I'd say all of them, yes. And some of them are going to be shut down because they can't, they aren't economical competing with low-cost gas. Others are just beyond their service life or reaching the end of their service lives, or like San Onofre that Craig summarized, they had mechanical problems that the utility said just wasn't worth repairing because they didn't have enough life left in the plant to justify the investment. So, the nuclear industry in this country is dead. Westinghouse was the largest producer of nuclear power plants. They basically sold their nuclear business to Hitachi, I believe it was, and then the Westinghouse Nuclear actually went bankrupt quite a long time ago. So the infrastructure isn't there either. And it would be quite a chore to rebuild it. But the other thing is nuclear itself. There's a couple of very big problems with nuclear that don't get solved. And I don't mean to disagree with Bill Gates. He's obviously a very capable guy. But the two in my mind are siting and the disposal of waste nuclear fuel. And Craig and I have been involved in watching this for 50 years, and the government has yet to come up with a solution for what to do with the spent reactor fuel. And what's happening today is all of the fuel that, for instance, San Onofre has used in its 28 years of operation are still on site, and they're going to be stored at that location forever until the government comes up with a solution. And
we have the same problem in Canada. You know,
yeah.
They've just been looking at sites where to bury this stuff, and nobody wants it. Anyway.
And then you have a whole issue of whether you reprocess it and how you dispose of it.
I'm going to get into that. Mm-hmm.
And so that is a huge problem, and that problem is not solved by any of the new nuclear plants. They will all have spent fuel that has to be disposed of. The other issue is nuclear power plants operate on a thermal cycle. They produce high temperature steam that goes through a turbine and then goes into a condenser. So by design, they require a lot of cooling water. And that's why they're on the coast or on the lakes and big rivers. And so, so when you build a nuclear power plant, you have a limited number of places where you can put it. And the population does not want a nuclear power plant anywhere near where people live. And I think it'll be very difficult to convince anybody that you can put one near big cities. And I think if you,
Pickering, not too far from here, on
yeah,
Lake Ontario, and you know, there are plans of what happens. You know, how are we going to get iodine tablets to people in time, and you know, little things like that. What are you going to do?
well, even if that's a infinitesimally small possibility, it's still enough to cause the public to be very concerned. So, like, I don't think you could get approval to put a new nuclear power plant anywhere in California, even though we have 1,000 miles of coastline.
Mm-hmm.
So I think that siting, even if you get these smaller nuclear reactors that people are talking about, and the other issue is I think that straight economics is going to be a big problem because solar and wind is getting cheaper and cheaper, and nuclear power plants have to be competitive for at least 40 years to justify the investment. And you know, it would take a big financial risk to spend billions on a nuclear power plant today and assume that you'll get your money back over 40 years. The one other thing is that nuclear power in the U.S. required, I think it was the Price-Anderson Act, where the government, the federal government, has assumed responsibility for the cost of any nuclear accident beyond a certain limit. So this subsidy would also have to apply to new nuclear plants as well. So I think there's you know, when you look at all of the problems about nuclear, we say there's a lot easier way to meet our energy needs going forward.
You have warmed my heart. I was afraid I was going to wade right in and have a fight with you guys.
No, not at all.
And I have to take my hat off to you because it must, I'm just trying to imagine what kind of transition you must have gone through. As a man who's spent his career, much of it, building nuclear power plants.
Well, I didn't spend a lot of time.
Well, it's your CV, as I've seen it, looks like you have a real background as a nuclear engineer and a businessman. So I'm thinking, how in the world does a man make a U-turn like that and come out sane?
Well, if I could give you a very short, you know, I was in the nuclear Navy and working as an engineer in Admiral Rickover's organization for 5 years. And that was a terrific experience. And then I worked for a company that produced commercial nuclear power plants for a couple of years. And at that point, I was probably about 28 to 30. I decided that nuclear power industry was not a good career opportunity. And so I switched careers. And that was probably the best decision I ever made.
Okay, so you did it while you were still young.
Yeah, I did. I was still young enough to make a change. Yeah.
You know, I read a book by Gregory Yachko, who was the head of the Nuclear Regulatory Commission. Is that what it's called?
Yeah.
And I think he got turfed out because he became anti-nuclear power. And basically his argument is, you know, he was surrounded by lobbyists for the nuclear industry. And they were in, you know, he was in Washington, and they go through their congressmen, they go through all the political system to exert their influence on him. And he said, and he was in charge of the regulatory commission at the time of Fukushima. So he even, you know, he went over there and was involved with it, trying to help out with that. His conclusion was that it's simply not going to be possible to keep enough autonomy for a regulatory commission to keep it honest, and that he found the pressures everywhere for him to compromise safety issues. And he said he couldn't imagine having a regulatory agency that was not affected by these pressures. Do you know anything about that? I mean, I think that's a remarkable conclusion.
I would say that in the United States, we've had a very good record on regulating our nuclear power. I mean, the Navy has done a superb job with nuclear reactor vessels, and we've never had an incident of any kind. And even commercial nuclear power has been very safe and very successful as far as operating. So I think there are pressures, cost pressures and so forth, but I think that the industry has done very well, in my opinion, as from a safety point of view.
Yeah, I would add to that I had a lot of interactions with the Nuclear Regulatory Commission on various projects we were involved in, and mostly related to seismic issues, because that was the main thing we were concerned about in California, at least where I was involved in it. And I would say I never had any experience of the Regulatory Commission yielding to any pressure. It was almost the opposite. In some ways, they made changes in the interest of safety and more strict designs and more higher standards for strength and durability and things of that sort, that the utilities had trouble keeping up with it. So they'd have a big project half built, and then the new regulations would come out and have to change supports for things like piping systems and electrical conduit supports and things of that sort. And that delayed the construction and added to the cost. So I kind of had the opposite feeling. I thought the Regulatory Commission probably overdid it in a lot of ways.
Yeah.
Okay, I'm encouraged to hear that.
Nuclear power is not going to save us.
Okay, that's the
bottom line.
That's the bottom line. Yeah. Okay. Good. But before we get to the bottom line, there are alternatives that we need to consider. That, if you don't mind, my dwelling on the nuclear, because maybe I'm unreasonable, but I think, right here in Canada, we have a big pressure to develop small nuclear reactors. And there's a real game plan. In fact, I think it's going to be in the throne speech when we have one coming up in Parliament soon. So I don't know how safe that is, or how realistic or how easy it would be to create a system of small nuclear reactors. Also, as I understand it, Bill Gates is investing in something called wave reactors. And I wonder if you want to say anything about what those would be and how they'd be different from the kinds that already exist.
I know Bill wants to answer this.
No, I don't. Well, I think we both have comments on this. And let me answer it. Any new reactor design, whether wave, there have been many different technologies over the years, but pressurized water reactors was the primary technology for the last 50 years. It takes a very long time to build a nuclear power plant and have it operating enough time to understand how safe it is and also understand the economics of it. We're now talking about all kinds of engineering studies. And then if you are going to build these small nuclear reactors, they're in a lot of ways, they're modeled after the nuclear reactors the Navy uses. They're about the same size. You'd have to produce hundreds of these, and then you've got to find places to put them. And they all need cooling water. They all have nuclear spent fuel to be disposed of. And let Bill Gates spend his money on that. I don't disagree with what he wants to do, but we think that solar and wind are available today. They work today. They're cheaper. They're better. They're getting better every day. They're getting cheaper every day. I just don't see nuclear power being a big part of the solution here. I'll go back to the other issue. I don't think you could get any nuclear power plant approved in the state of California today, no matter who designed it.
Well, I think that's wonderful. I feel better already.
Yeah.
So maybe I should change the subject and stop forcing you to talk about something that is not really on your minds.
Yeah.
Let's go back to talking about how you are going to save the world. And,
I can answer that one either.
Well,
yeah, tell us about your game plan. What how are you going to get? I think the question is, how are you going to do it quick enough, moving the solar and wind up to account for much more than coal and gas, which now take the lion's share of the sources of power, at least in the U.S. How are you going to move it fast enough? And how are you going to create the storage that is necessary to make it work when the sun's not shining or the wind's not blowing?
I wrote a book about efficient energy use in 1980 called Energy Management Principles. And I was motivated to do that because we'd been doing some work for the Electric Power Research Institute. And after the Arab oil embargo in 1973, I noticed a phenomenon that suddenly the economy was starting to come back. Oil prices were 3 times as high as they had been. But energy consumption in the country and in the world was flat. So what was happening was that we were finding more and more efficient ways to use energy and to use electricity. And over the years, I followed this by just partly personal interest, but I also was asked to write some chapters and handbooks and things over 20 or 30 year period. And in 2016, I decided to do a complete update, wrote a second edition of that book, and which was also published by Elsevier. And it was remarkable to see how much, in terms of dollars of gross domestic product per unit of energy, how much it increased over that time period.
What increments? The
energy, the gross national product output for a given unit of energy increased. So
that's an interesting way of measuring things.
Yeah,
that sounds like a good statistic to pay attention.
Very important statistic. Yeah.
And Bill and I tracked this over the recent period of time, and it's been averaging about 2% per year for a long period of time, even in the last 20 years or so. So the first measure we think is that we can increase that to 3% per year. We can add 1% to it. Some of that's going to happen automatically just by market forces. But to explain how that could have come about, in 1980, if you went into your local hardware store, maybe you'd find some low wattage fluorescent lamps. That was it. You go into a Home Depot or the Canadian equivalent of that today, you'll see a 100-yard long shelf with all kinds of LED lamps and automatic timers and thermostats and smart controls and high efficiency refrigerators. I mean, just refrigerators, the amount of energy to operate a refrigerator has dropped over 50%. And costs have gone down. It's just, there've been some amazing improvements. So we see that as continuing, and we've calculated what we think that would do for reducing greenhouse gases. And the basics, let me just stick these numbers in your mind as we continue. We believe that business as usual, if we don't do anything today, 2019, the world emitted 55 billion metric tons of greenhouse gases into the atmosphere.
2019, you say?
Yes.
2019.
55 billion
metric tons of greenhouse gases.
Okay.
So business as usual, we forecast with our models, which are not anything great and sophisticated, but at any rate, that by 2050, it'll be 80 million.
80 billion, yeah.
Billion metric tons of greenhouse gas, if we don't change anything from what we're doing today.
Ouch.
Yeah, ouch is right. So what we've done is then for things like the 1% improvement in energy efficiency over the next 30 years, that's going to reduce that amount by some number. I'm doing this from memory, so I don't have any notes or anything, but it's going to be 3 or 4 billion metric tons, somewhere in that range.
3 or 4 out of the, we're talking 3 or 4 out of 80.
Right, 3 or 4, something like that.
Mm-hmm.
I know the total, but I don't remember.
Yeah.
Yeah.
Anyway, Bill, you go on. You tell about the next one.
Oh boy, you better do better than that, Bill, because he's not encouraging me a bit.
Well, I mean, there's 5 or 6 things that have to be done, and I mean, one is we think the probably the least expensive in many ways is improving energy conservation and efficiency, as Craig has just discussed. And there are lots and lots of ways we can get more output with using less energy. The other one is
I thought you were saying, I got lost, because I thought he was saying if you went up from 2% to 3%, increase in this funny statistic of yours.
Well,
that,
let me jump in for just a minute, Bill.
Yeah, sure.
Over the decades, I did a lot of work for different utilities, including PG&E and Edison and others. And the contracts we had with my company at that time was to design energy rebate programs. So the utilities were getting money or credit for money from the regulatory commission if they gave money back to their customers for things like installing LED lights and so on. So just jumping right ahead real briefly is that if today all the investor-owned utilities were mandated to set up similar rebate programs for their customers, we could get 1% additional efficiency absolutely easy.
Easy.
okay, but now when you were calculating this 1 additional percent efficiency, is that how you're going to get an extra 5 billion, lop off an extra 5 billion out of this 80? Or, but still not enough, fella.
Well, I mean, the thing that we've got about 5 or 6 must-do things. And
sorry, be quiet now.
Yeah, but conservation efficiency is a big deal in our mind.
All right.
And, you know, an extra 1% a year gets you almost a 30% improvement in 30 years. So that's a lot. The other thing is we need to produce all of our electricity from renewables. Basically, they're fuel-free, and so and obviously the first step would be to reduce the use of coal, and that's happening in the U.S. because we have abundant natural gas. In places like India and China, they do not, so they're still heavily dependent on coal. So we need to produce electricity from renewables instead of fossil fuels. Then the other one, we need to get rid of internal combustion engines over time. We need to basically convert all of our vehicles, and this is over time, from oil-based or gasoline and diesel to electric power. And that's already happening. I mean, one of the things we would say is the trend is our friend. All of the things that we think have to be done are being done today. They're just not being done fast enough on a big enough scale. So it's not like
look, if you switch from gasoline cars to electric cars, you're still going to have to get your electricity, and then
that's why you have to produce it from renewables.
Working this out so that you're still better off if we electrify everything. Our kitchen stoves and everything, we're going to be able, that's a safer bet. We can still do that, in other words, and create the electrical energy with renewable sources.
Yeah, there's no question that we can produce enough electricity from renewable sources. And then if we all switch to electric vehicles tomorrow and produce the electricity with fossil fuels, we haven't gained anything.
Mm.
So we really need to use renewables to produce electricity. Then we need to go to electric vehicles. We need to change industry to use electricity as a source of heat and power where they're now using fossil fuels. And we also feel that there's going to be a need, and it'll become practical in time, to produce liquid fuels and gaseous fuels from recycled CO2 if electricity is cheap enough. And so there will be some, like aviation, you can't really have electric airplanes flying across the Atlantic. You'll need fossil fuels, but those could be produced from recycled CO2.
Tell me about what you think about this engineering, this David Keith's thing up in BC, where he's sucking CO2 out of the ambient air and turning it into a fuel. I have friends who tell me that's crazy. It's not going to work, or it's not going to be economical.
Bill just done a very detailed analysis of that.
Yeah. Well, we have studied what they're doing. You know, we're not experts, but and that would be potentially valuable. But if I guess there's a couple things to remove CO2 from the atmosphere, and we've got this in a paper that we've just finished. It's very expensive, and it also takes a lot of energy to remove CO2 from the atmosphere. And to do that as a way of reducing global warming, we think would be prohibitively expensive. If they can get the cost down to remove CO2 from the atmosphere and then use that CO2 to be recycled into synthetic fuels, that may have an opportunity. But to do that, you'd have to power the process by using renewable energy, and then the electricity would have to be cheap enough so that the fuel that you produced would be economical to use. So there's a long way to go in our mind, but we certainly think that that's a worthwhile effort.
Well, that you're confirming what a friend of mine, an engineer, said. And she goes on to say she would actually prefer an interest in carbon capture from things like directly from smokestacks and so on. I'd heard that is an unrealistic, uneconomical thing, but she thinks there's more potential in upgrading that than what they're doing in BC.
Well, Meta, I mean, excuse me, one comment. I mean, I think that there's a couple things. The things we need to do are straightforward, and they're being done today. We just aren't moving fast enough. Then when you start to talk about what about nuclear power, what about carbon capture, what about some XYZ technology we haven't invented yet? I mean, these are all things that, you know, there's no harm in pursuing these, but they're not going to get us there very fast, and they've got a long way to go before they can be like carbon capture. How big a carbon capture installation would you have to produce to make a difference? It would have to be a huge number of plants around the world, and who's going to pay for all that when there's no market for the carbon you're taking out of the atmosphere? The way you could make it economical is if you had a carbon fee that was more expensive than the cost of removing the CO2, then there'd be an incentive to do it. But, you know, I think these things are not going to save us, and the answers are pretty much more straightforward.
The last conversation I did was with a guy named Seth Klein in Vancouver, who has an axe to grind. He really doesn't believe that the carbon taxation that was instituted in British Columbia has really reduced carbon emissions much. And he thinks he would bet more on regulation than on carbon pricing. And I think he's almost alone in that. Tell me what you think.
Well, as I mentioned earlier, I've studied the efficiency versus cost of energy since the 1973 oil embargo. And to me, it was just almost a form of putting a fee on carbon. In other words, the price of crude oil tripled overnight. And as a result of that, people found ways to use energy more efficiently. And that curve remained flat for like 2 decades. It's remarkable. So I think you can draw an analogy between that. If you impose a fee on carbon, it's effectively raising the price of fossil fuels. People are going to find ways to get around using them. I mean, it seems to me it's just obvious. It's no doubt about it. Now, people argue because they, oh, well, taxes are terrible and all that. We say, well, it's not a tax, it's just a fee. It's making those oil companies and coal mines pay for this crap they're putting in the atmosphere, and they've done it willy-nilly for 100 years for free, and they've cost a lot of people their lives, and there's a lot of public health issues from it even today. A lot of miners died from black lung disease, and fish died from refineries and oil platforms blowing up. And so it's time they paid the piper. And if they paid for some of those costs, which we all are paying for indirectly anyway, that would make their products price more reasonably. It would make the advantage of the renewables much more visible.
Craig, I'd like to add something too. I mean, right now, like in California, we have a cap and trade system, and I think they're even teaming up with one of the Canadian provinces. Yeah. And we think what we talk about is a carbon fee that would be applied at the wellhead or the mine and be unavoidable. You can't game the system, you can't avoid the tax. But when you get into cap and trade, people are trying to determine emissions levels, and then you get all kinds of special treatment. You can have politicians and special interests game the system. So the more complicated it gets, the worse or the less effective it is. And so we really feel that if we're serious about global warming, and I think both of us would agree with this, if you're not interested in a carbon fee, you're not serious. I think that would be
clarify a little bit the difference between what you call a carbon fee and a carbon tax. I'm used to hearing about carbon taxes, but are you talking about anything different, or is it just different language?
No, the same.
In the word tax because of the connotations of it. In other words, if you produce so many barrels of oil at a given oil well, that's equivalent to so many tons of carbon dioxide once the oil is burned. And you're going to pay $40 a ton. It's going to be charged right then and there. So that's it.
All right. I think a majority of other people do agree with you, right? That carbon taxation or carbon fees would be the most promising solution, and that regulation is harder.
No, regulations aren't going to do it.
They get gamed.
Yeah, that's what I figured. Yeah.
Meta, one question, one comment I'd like to make there. You can say that it's just a matter of semantics, a tax versus a fee, but I think there's a very important difference. A tax is something where the government is taking something away from you to pay for government, and that's all necessary. But a fee is what we're saying. It's not a tax as much as you are now putting greenhouse gases and other pollutants into the atmosphere for free, and it shouldn't be free. There should be a fee associated with that massive discharge of greenhouse gases into the atmosphere. It can't be free. And I think a fee is a much better term than a tax.
Okay.
There's another component to that, Meta, and that is you've probably seen numbers on how much we are currently subsidizing the fossil fuel companies today. around the world. So the main things are, you know, we have an oil depletion allowance. We have
I
mining.
have a friend in Europe who estimated, I don't know where he got his number, he swears that there are $5 trillion a year subsidies globally. You think
Right.
that's reasonable?
That's a World Bank study came
Is
up
it?
with that number. Yes, it's a pretty authoritative number.
Yeah. Now, if we could just wave that number around in people's face, that should do something to change public opinion. And that's really where I get stuck. I think I spend all my time trying to, you know, have these conversations and try to get people to think about these issues. And I don't think we're making much progress.
Why are we doing that today?
Yeah.
Well, Meta, can I go back to the end of your earlier question, and that is, I hope I fixed in your mind 80 billion metric tons of greenhouse gases if we don't do anything. And Bill summarized all the rest of the measures that we have in our, what we call our action plan. And those will reduce, I had to go make sure I have the right numbers here. They will reduce that 80 billion metric tons by roughly 35. And so we'll end up then actually with 47 billion metric tons of greenhouse gas emitted in 2050. And that gets us back to roughly where we were in the year 2000. So that's not net zero. That's still a ways from net zero.
Right.
But our point is that we have to get started, and we have to do as much as we can. Now that's over 30 years. And if you compare that to the kind of what we think of wild statements about, oh, we're going to be at net zero in 2040 or 2050, not going to happen. Not going to happen for the world. Certainly it won't happen for the United States. California hopes to.
Okay. Yeah, but you guys are talking just about reducing emissions. I think everybody, I don't think just a reduction of emissions could by itself do it. We actually have to do some sequestration. We have to suck the stuff out of the air and put it away. And then you've got things like, you know, regenerative agriculture and reforestation and a bunch of other things that become possible, which, have you tried looking at the combination of reducing emissions, which you're focusing entirely on that, but combine that with some estimates about how much you can do by just adding another trillion trees, for example.
Can I mention that? I mean, Craig mentioned that we have just finished a blog post, which is where we look specifically at removing CO2 from the atmosphere. And we used the numbers that your Canadian firm and others have been putting out, and it can be demonstrated to reduce the CO2 concentration in the atmosphere only 1 part per million, a very small amount, would cost over $1 trillion.
To do what?
To take enough CO2 out of the atmosphere.
Oh, you mean this guy, NBC, this David Keith?
Yeah, or others. I mean, there's,
okay, but what about planting trees, for example, or plant, you know, good agriculture?
First of all, to think that we can economically take CO2 out of the atmosphere is not, I mean, right now with the numbers that are reasonable, it would cost $1 trillion to make a very small reduction.
Yeah, but trees do it.
Well, trees, you'd have to plant a billion trees.
You have to plant 1 trillion trees. In fact,
well, say 1 trillion trees, yeah.
2 trillion trees probably to get 1 trillion survive.
Yeah.
Yeah, it's a lot.
We support that.
That will help.
we didn't discuss it, but we've included things that you can, in our plan, that can be done with agriculture and planting trees and stop deforestation and so on. Those other measures account for about 1/4 of the total greenhouse gas that the world puts into the atmosphere. So we can't neglect that. But the pie and the sucking carbon out of the atmosphere is on.
Oh, okay. It's no luck. What's your plan for storage?
You're right. That's a very important need. It's the combination of distribution systems and transmission systems that need to be changed to handle intermittent power sources like wind and solar. And that goes clear down to the level of the customer's meter. But today, there's a huge amount of work going on more efficient batteries, cheaper batteries, bigger capacity. And so they're coming. And
Okay.
we can see that coming. It's happening today.
I think probably we need some sort of concerted game plan at the global level, but I can't see anybody who's up for that, even would dare to offer such a thing at the moment.
Well,
What's your notion of how we're going to get from here to there?
the mechanism, there's the Paris Agreement or the Paris Accords, which is a large international agreement, and almost every country in the world is a member. So there's an effort underway to get the global cooperation needed. Unfortunately, the U.S. Has not been an active member, and the Trump administration has indicated that they want to actually leave the Paris Agreement. So that's a step in the wrong direction. I think the Paris Agreement is a big step in the right direction. They've got pledges from each country as to what greenhouse gas reductions they're going to achieve. The problem is there's no enforcement mechanism, and essentially all the countries are behind in their commitments. So, we need to do better, but there is a mechanism in place, and I think most countries in the world are taking a lot more seriously than the United States. And I think we need to step up to become not only a part of the Paris Agreement, but we need to be more of a leader.
Total support for that.
Yeah.
Thank you so much. I found it very informative, and I've learned a lot. Thank you.
Well, thank you for having us, Meta. That's very kind of you.
I'm going to say goodbye now. Okay.
Thank you.
Yeah.
Bye.
Bye.
This conversation is one of the weekly series Talk About Saving the World, produced by Peace Magazine and Project Save the World. Please visit our website at tosavetheworld.ca, where you can sign the Platform for Survival, a list of 25 public policy proposals that, if enacted, would greatly reduce the risk of 6 global threats to humankind. Come back next week for another discussion of a serious global issue.